Okay, so next we want to run bubble plots to show three-dimensional plot, not in the sense of 3D modeling, but how do we show three independent variables values summarized as a plot, a two-dimensional plot, and also 4D plot, right? So 3D plot, 4D plot. In the classroom, the slide classroom that in the previous video segment, we discussed that the third dimension is given by the size of the bubble. And the fourth dimension is given by the color of the bubble. Okay, so when we are able to feed the data into the size based on the data, you have different size. Of course, your df.plot.scatter must react to it. Some modules are not designed or coded to be able to understand a series as size. Then you will complain about error. No, your size has to be fixed because it's not able to interpret that. But fortunately, Python's scatter plot can absorb series for size, can absorb a series for color. Okay, so what we do is that we will run this first and see what's the effect. Remember, our first thumbnail is always the pie chart, huh? But it's okay. We can identify the new charts here. So for this, basically, the new chart shows what we saw in the classroom, that accordingly, the bigger the value in the df.b, the larger is our plot. Now, sometimes the df.b is measured in smallish scales. For example, because we recorded as tons or thousands of kilometers or millions of dollars, right? So the numbers are going to be 1.5, 1.6, 2.1. And if you use directly that number, because it's in millions, right? If you use directly, it becomes 1.5 pixel in radius, 2.1 pixel in radius, and then you won't see much of a difference. So what you need to do is something like this, multiply by a scale, the scale to make that 1.5 million and 2.1 million distinguishable graphically. All right, so this times 50 by no means here changes the data, but scales the data for appropriate drawing on the screen in the charts. Okay, so likewise for the color, I show you one way to deal with color. Now, for discrete data, which is what we have in A, just a quick reminder: A is a column having ones, twos, and three, right? So just three distinct values. So each this is first of all a discrete data, meaning that we consciously want to have just 1, 2, and 3, and it will repeat. So we know that A wouldn't get more than 3 distinct data. Now, sometimes we may be also having a short data frame, maybe 7 values, but they are storing money. So money, the more and the less, it's quite comparable. So we may have 1.1, 1.5, 1.7, 2.9, right? That doesn't mean we have only 4 distinct data and therefore treated discretely. It will become continuous because 2.9 is way more than 1.5, right? So that distinguishes between discrete categorical data in A versus continuous numbers in A. For continuous numbers in A, we might want one color but with different intensity, right? So we want like very bright red for very large debt, and then scale to 0, and then scale to very bright green for having a lot of money. And that would be very visually telling. So, but here, let me just show you the color map rather than color gradient, right? So the continuous case, we'll use color gradient. For discrete case like this, we say 1 is to map to red color, 2 is to map to lime color, 3 is to map to royal blue or blue, whatever you want, right? These names are color codes that are, or names of color codes that Matplotlib and PyPlot understands. So we can just directly tell the name. For the color map here, why do we define this dictionary? This is a dictionary because we're going to feed it to this series. Remember, df.a is a series, right? This column is a series. So we apply the map, which will supposedly take a lambda, and for each cell in the series, run the lambda, get the value, and replace it back, right? We talked about this in our data analytics video segments, how we can do programmable content transformation, right? So this is exactly it. In place of lambda, we just need a dictionary, a map, isn't it? A map is to map from one old value to a new value. And that's exactly what this dictionary does. So we can feed it with a dictionary and it is complete in the knowledge. Whenever you see one in A, change it to red. So let's do that, right? So we have three reds, three ones. Whenever you see two, change it to lime green, right? And we have 1, 3 here. Whenever you see 3, change it to royal blue. So 3 categories. And then the size is still defined by the B's column, scaled by 50, and then C versus D. So very powerful bubble diagrams. Remember this using dot scatter, 3D, 4D. A lot of information can be summarized here, uh, where in occasions where we have no idea how these 4 variables, 3 variables, 2 variables interact with each other. And we want to see a pattern using our eyes. This is it, right? So if you're doing a lot of data analytics exploratory manner, that means we didn't know what the data is supposed to be telling us. It is new to us. We're trying to learn from the data. So when you're doing this, definitely consider 2D, 3D, 4D bubble diagrams using scatter plot. Very, very useful. Okay, next up, let's clear the screen and get ready to run time series. Okay. So I think we have seen line charts being run. It's kind of nice to let it run through so many uh, uh, charts and graphs. So we have seen line charts. This is already a time series where time is discretized, right? So each integer time is one constant duration snapshot of the variable. So example, if C represents stock price, then time zero is when we first look at the stock price, end of day stock price, for example. Next day, end of day, we record the stock price. Next day, end of day, we record the stock price. So this will be 0, 1, 2. Now this is nice for personal, within organization, within team analysis, where we all understand. This is nice if you're having academic exercises where we learn about forecasting using discrete time. That's fine. But when you need this to be generated for your customer, who is probably not going to look at this very kindly, if you're going to generate this for your PowerPoint presentation meant for greater audience, you don't want this cryptic looking time on the x-axis. So now the question is, how do we do that in Python, right? To make the time appear nicely. The time here, I just use generically, can be date, time only, or date time. Okay, so we know that they are very different and how we treat them is very different. So what we can do is we can make use of the shape to know how many rows and columns. We know that, right? And then use this very nice Pandas range generator, date range. So date range generates a series containing date type. So date type is, of course, special. It's not string, it's not integer, but it represents date. What does that mean? It means date type is aware of, like, 30th is the last day of April. If you plus 1 to April 30th, we don't get April 31st. We get 1st May. Yeah. But if you plus 1 to 30th of May, you don't get 1st June, you get 31st of May. All these must be correctly calculated. But more importantly, on leap years, like 2020, right? You plus 1 to February 28th, you don't get 1st March, you get February 29th. So you need to have pretty, careful code to deal with all this, and Pandas already has that. So another nice Pandas function to look at is to date time. This is another very useful function to convert string dates into date time dates. That means internally it's aware of the dates and the times, and that is good. So you want date time types to be stored in df index and not just a plain string representation, because string representation you cannot plus one to the string. All right, you cannot plus one to the date, you cannot plus one to the hour, things like that, right? So I'll leave the function name there. So what this does is that well, let's just run it. Let me just clear screen. Originally, we know that the df index was just if we have a copy earlier on, it's going to be 0, 1, 2, 3, 4, 5, 6, 7. Oh, because we have too many charts here, right? So let's look at our df right now. The index is a very nicely formatted date like this. Look at that. It's beautiful, right? Beautiful. So here, when we plot, well, we can plot C, for example. Okay, we have a new figure. Then we plot C, and that's the Y value. What's the X value? The dot index, right? And it is time. It is date aware. And then we have the grid, but that's just easy, right? So